Gravity is often introduced as the weakest influence in nature. Compared to electromagnetism, it appears insignificant. Compared to the forces that bind atomic nuclei, it seems almost irrelevant. A small magnet lifted by a human hand can overcome the gravitational influence of the entire Earth on a piece of metal. On the surface, gravity looks like a background effect, a gentle tendency, something that matters only because there is so much mass in the universe to compensate for how faint it is. This is the first misunderstanding. Gravity is not important because it is strong. Gravity is important because everything that exists quietly assumes it will never disappear. Every structure, every process, every story the universe tells itself is built on the expectation that gravity will always be there tomorrow, behaving the same way it behaved yesterday. When gravity is described as a pull, the description already fails. There is no invisible rope tying Earth to the sun. There is no force line stretching across empty space, dragging planets inward. Nothing reaches out and grabs. What we call gravity is not an interaction acting inside the universe. It is the way the universe arranges itself. In the language of modern physics, gravity is geometry. Matter and energy do not attract each other directly. Instead, they shape the structure of space-time itself. Space-time responds by telling matter how to move. Objects follow the straightest possible paths they are allowed to take, and those paths only look curved because space-time is curved. A planet in orbit is not being pulled. It is falling freely along a path carved into reality itself. A black hole does not suck matter inward. It reshapes space-time so completely that all possible paths lead deeper inside. Even a person standing still on the surface of Earth is not being pulled downward. That person is trying to fall freely through curved space-time and is being stopped by the ground pushing upward. This distinction matters because it reveals something unsettling. Gravity is not something layered on top of the universe. Gravity is something the universe is doing to itself continuously. It is an active rule that defines how space and time behave from moment to moment. Every structure that exists depends on this rule. Stars exist because gravity compresses clouds of gas until their cores reach temperatures measured in millions of degrees Celsius, igniting nuclear fusion. Planets exist because gravity allows debris to collide, merge, and remain bound instead of drifting away forever. Galaxies exist because gravity links billions of stars into rotating systems that persist for billions of years. Even chemistry owes its long-term stability to gravity at a cosmic scale, because gravity creates environments where atoms can form, remain together, and experience relatively gentle conditions for extended periods of time. Without gravity, particles would still exist, fields would still vibrate, energy would still flow, but nothing would stay together long enough to matter. The universe would have no preference for togetherness over separation. Every other process assumes gravity has already made that choice. Stability is not automatic. Left alone, energy spreads. Differences fade. Temperatures equalize. Entropy increases. Gravity does not stop this trend, but it reshapes it. Gravity creates regions where matter piles up, where energy gradients form, where complexity can grow locally, even as the universe as a whole moves toward disorder. A star is an engine that increases entropy by converting low-entropy fuel into high-entropy radiation. Gravity makes that engine possible by concentrating matter enough for fusion to begin. A galaxy funnels matter into stars, stars into remnants, remnants into black holes. Gravity holds this hierarchy together long enough for each stage to occur. In this way, gravity gives time something to do. It creates hills and valleys in the thermodynamic landscape. It allows processes to unfold in sequences instead of flattening instantly into equilibrium. Without gravity, entropy would still increase, but it would do so uniformly. There would be no stages, no structures, no long arcs of change. Gravity also shapes causality itself. Cause and effect feel fundamental, but they depend on space-time structure. Gravity bends the paths of light. It slows clocks near massive objects. It creates horizons beyond which information cannot return. Even mild gravitational fields subtly alter which events can influence which others. In extreme cases, such as black holes, gravity draws a boundary where causality ends. Events beyond that boundary no longer belong to the future of the outside universe. They are removed from influence entirely. These effects are not side consequences. They are the direct imprint of gravity on the flow of information. Gravity decides how signals propagate, how long they linger, and where they can be stored. A planet remembers its formation through its orbit. A star remembers its mass through its lifespan. A galaxy remembers past mergers through its shape and motion. Gravity stores history in structure. Without gravity, the universe would become forgetful. Particles could still collide, but nothing would preserve the outcomes. Energy could still move, but nothing would trap it. Information could still exist, but nothing would hold it long enough to accumulate meaning. Memory requires structure, and structure requires gravity. This is why imagining the loss of gravity as an explosion is misleading. Gravity is not a glue that snaps. It is a rule that stops being enforced. When gravity disappears, nothing is pushed outward. Nothing is flung violently away. Objects simply stop being told to follow curved paths. They continue in straight lines that only seem dramatic because curved motion was expected. Galaxies do not tear themselves apart. They quietly lose the reason to remain bound. The danger is not force. The danger is the absence of constraint. Every law of physics you are familiar with quietly assumes gravity exists. Quantum fields assume a space-time background. Thermodynamics assumes gradients that persist. Chemistry assumes long-lived environments. Biology assumes stability across time. Gravity is the condition that allows these assumptions to hold. If gravity is fundamental, then this rule is unbreakable. But if gravity is emergent, if it arises from deeper principles involving information, entropy, or quantum entanglement, then gravity is something produced rather than guaranteed. And anything that is produced can fail. To imagine a universe without gravity, we must ask a deeper question than what would happen if a force vanished. We must ask what it means for the universe to make gravity at all, and what reality becomes when that process stops. Gravity does more than hold things together. It gives the universe a sense of direction. Not direction in space, but direction in time. When matter collapses under gravity, when stars ignite, when galaxies assemble, something irreversible happens. The universe moves from simpler arrangements to more complex ones, and then slowly back towards simplicity again. Gravity creates the conditions for that arc to exist at all. Without gravity, time would still pass in the mathematical sense, but it would lose much of its meaning. There would be no long-lived processes unfolding across millions or billions of years. No slow births and deaths of stars. No accumulation of history. Events would happen, but they would not stack into narratives. The universe would become a sequence of unrelated moments rather than a story. This is because gravity is deeply entangled with how the universe remembers its past. When matter falls into a gravitational well, information is concentrated. Paths become predictable. Patterns repeat. Orbits form. Cycles emerge. Gravity creates persistence. It allows causes to echo forward through time instead of vanishing immediately. Consider a simple example. A planet orbiting the Sun carries information about the mass of the Sun, the shape of space-time around it, and its own formation history. That information is stored in motion. Remove gravity and the orbit disappears. The planet continues moving, but the memory encoded in its path is erased. What remains is motion without meaning. Scale this up, and the effect becomes profound. Galaxies are not just collections of stars. They are records. Their shapes preserve evidence of ancient collisions. Their rotations remember the distribution of dark matter. Their stellar populations encode billions of years of formation and destruction. Gravity is the mechanism that writes this memory and keeps it legible. Even black holes, the most extreme objects known, are expressions of gravity as memory. A black hole forgets nearly everything about what formed it, but it remembers mass, spin, and charge. More importantly, it remembers entropy. The area of its horizon measures how much information has been hidden away. Gravity does not merely destroy information, it organizes where information can go and how it can be stored. This is why gravity is inseparable from causality. In a universe with gravity, not everything can influence everything else. Distance matters, time delays matter, horizons matter. There are regions you cannot reach and events you cannot see. These limits are not inconveniences. They are what allow cause and effect to remain meaningful. If every event could instantly affect every other event, causality would dissolve into noise. Gravity enforces locality. It makes the universe compartmentalized. It creates neighborhoods in spacetime. Without gravity, there would be no reason for influence to respect distance. Signals would propagate, but nothing would shape their relevance. Information would smear across space too quickly to be useful. This reveals another subtle role gravity plays. It allows ignorance. It allows parts of the universe to be unaware of other parts. This separation is essential for complexity. Life requires environments shielded from overwhelming influence. Stars require isolation to burn steadily. Galaxies require relative calm to persist. Gravity creates pockets of partial isolation in an otherwise connected cosmos. Without gravity, the universe becomes too open, too exposed. Everything influences everything else too evenly. Differences cannot persist. Complexity cannot hide long enough to grow. This is why gravity cannot be treated as just another interaction like electromagnetism. Electromagnetism acts between charges. Gravity defines what it means for there to be distance between charges in the first place. It tells space how to behave and time how to flow. Remove it, and the stage itself changes shape. At this point, a dangerous assumption often slips in. The idea that gravity must exist because space-time exists, that curvature is inevitable. But modern physics suggests this may not be true. In many theoretical frameworks, gravity is not fundamental. It emerges from deeper layers of reality, from the statistics of microscopic states, from the flow of information, from patterns of quantum entanglement stretched across space. In these pictures, space-time itself may not be primary. Geometry may arise the way temperature arises, not as a fundamental property, but as a collective behavior of many underlying degrees of freedom. Gravity, in this sense, is not a law carved into the universe. It is a habit the universe has learned. Habits can break. If gravity is emergent, then it is produced moment by moment. It depends on conditions being right, on information being arranged in specific ways, on relationships between quantum states being maintained. If those relationships fail, gravity does not weaken, it stops. This is the conceptual cliff edge, the realization that gravity might not fade gradually, it might simply fail to appear. And if that happens, the universe does not shatter, it does not scream, it does not explode. It forgets how to hold itself together. In the next part, we will step into that moment. The instant gravity stops being produced. The instant curved space-time relaxes. The instant every object is released from the rule it never knew it was obeying. Imagine the rule ending without announcement. No countdown, no warning ripple moving at the speed of light. Gravity does not flicker or weaken. It simply fails to be produced. Space-time does not tear, it relaxes. The curves flatten. The instructions that once told matter how to move are no longer written. Nothing feels it immediately. A planet does not feel a jolt. A star does not shudder. A galaxy does not scream. Every object continues doing exactly what it was doing an instant before, because inertia remains, motion remains, energy remains. What vanishes is the guidance system that shaped those motions into meaningful paths. Orbits are the first illusion to die. An orbit is not a thing. It is a pattern that exists only because spacetime is curved in just the right way. When that curvature disappears, the pattern dissolves. The planet does not fly away. It simply continues forward along a straight path it was never allowed to take before. The sun does not lose its grip. It never had one. The geometry that made straight motion loop back on itself is gone. On Earth, there is no shockwave, no tremor, no sound. The ground does not crumble. People do not feel lighter. For a brief moment, everything seems normal. But that normality is already outdated. The planet is no longer a planet. It is a loose cloud of matter moving in nearly the same direction. The atmosphere begins to drift, not upward, not outward explosively, but sideways. Molecules no longer curve back toward the center of the planet. They follow straight lines that slowly peel away. The oceans do not surge. They spread. The distinction between up and down loses meaning, not because things fall upward, but because falling no longer exists. Inside Earth, the pressure gradients that once depended on gravity no longer make sense. The planet does not collapse. It decompresses. Layers that were defined by weight begin to mix. Over time, the idea of a surface fades. Earth becomes a smear of rock, water, and air, expanding silently into space. The same thing happens everywhere. Stars do not instantly explode. Nuclear fusion continues for a short while because the reactions are already underway. But without gravity, there is no confinement. The plasma begins to expand. Temperatures drop. Fusion stalls. Light still pours outward, but the engine that sustained it is dying. Each star fades not in a flash but in a quiet exhaustion. Galaxies unravel with eerie grace. The spiral arms do not tear. They unwind. Stars drift along paths that once curved and now straighten. The cosmic web that connected clusters across millions of light years loosens. Filaments thin. Voids expand. The large-scale structure of the universe dissolves not through violence but through indifference. This is what makes the loss of gravity so unsettling. There is no single dramatic moment, no explosion to mark the end. The universe simply stops correcting itself. Every deviation that gravity once nudged back into place now persists. Small differences grow, alignment is lost, coordination fades. Space-time itself becomes simpler and poorer. Without gravity, there are no preferred paths, no geodesics guiding motion. Light still travels, but its journeys lose context. Lensing disappears. Focusing disappears. Information spreads more evenly and more quickly. Signals overlap. Distinctions blur. Time keeps ticking, but its texture changes. Without gravity, there is no gravitational time dilation. No clocks running slower near massive objects. No variation in temporal flow across space. Time becomes uniform and flat, like a metronome clicking in an empty room. Entropy still increases, but now it does so without resistance. There are no structures to slow it, no pockets of order to delay it. The universe rushes toward uniformity, not the heat death imagined in textbooks, but something stranger, a rapid flattening of differences, a premature stillness. Information disperses faster than it can be used. Without gravity to trap energy, to store records in orbits and structures, memory evaporates. Every interaction leaves a trace, but the trace is too thin to matter. Nothing lasts long enough to become history. Black holes cease to exist in any meaningful sense. Without curvature, there can be no horizons. The regions that once hid information are no longer sealed. Whatever was contained is released, not as a burst, but as an unstructured fog of radiation and particles spreading into an already thinning universe. Even the concept of inside and outside loses clarity. What remains is not nothing. It is worse than nothing. It is a universe full of ingredients with no recipe, matter without gathering, energy without focus, time without narrative, change without direction. This is not destruction. It is forgetting. Gravity was never just an attraction. It was the universe remembering how to be itself from one moment to the next. When that memory fails, reality does not collapse. It dissolves into motion without meaning, existence without persistence. This is the end of the chapter, but not the end of the story. What follows is a deeper unraveling, how structure dies, how time loses its arrow, how a universe without gravity becomes a place where nothing can ever truly begin again. To understand how gravity can disappear, we must first confront an idea that feels almost heretical. Gravity may not be a fundamental ingredient of reality. It may not be woven into the universe at the deepest level. Instead, it may be something that emerges only when the universe is arranged in a particular way. This is not speculation for the sake of drama. It is a conclusion that modern physics keeps circling back to again and again from different directions. When scientists try to unify gravity with quantum mechanics, gravity behaves strangely. It resists being treated like the other interactions. It refuses to fit neatly into the same mathematical language. It behaves less like a force and more like a large-scale consequence of something deeper. In general, relativity, gravity appears as curvature. Mass and energy shape space-time, and space-time shapes motion. This description works astonishingly well. It predicts black holes, gravitational waves, time dilation, and the expansion of the universe with breathtaking accuracy. But it leaves an uncomfortable question unanswered. Why should space-time curve at all? General relativity tells us how gravity behaves, not why it exists. When physicists look beneath space-time, they find hints that geometry itself may not be fundamental. At very small scales, the universe appears grainy. Information becomes discrete. Quantum states dominate. Space and time begin to look less like a smooth fabric and more like a statistical outcome, something that emerges when countless microscopic elements act together. In this view, gravity is not a basic rule. It is a large-scale pattern, similar to temperature. Temperature feels fundamental in everyday life, yet it is not a property of individual particles. It emerges from their collective motion. If the particles stop moving in the right way, temperature disappears without violating any deeper law. Gravity may be similar. Some theoretical models suggest gravity emerges from entropy. In these models, space-time rearranges itself to maximize information flow. Matter moves not because it is pulled, but because the universe is statistically biased towards certain configurations. Gravity becomes an entropic tendency, a bookkeeping effect of how information prefers to organize itself. Other models suggest gravity emerges from quantum entanglement. In these pictures, space-time is stitched together by correlations between quantum states. Distance itself is not primary. It arises from how strongly regions are entangled. Gravity then becomes a reflection of how these entanglement patterns change when energy is added or removed. In still other approaches, gravity appears as a collective excitation, like a vibration of an underlying informational network. Space-time bends not because it must, but because the network responds dynamically to stress. What all these ideas share is a radical implication. Gravity is not guaranteed. If gravity is emergent, then it depends on conditions being maintained. On relationships between microscopic degrees of freedom remaining intact. On information continuing to flow in specific patterns. Gravity is something the universe produces moment by moment, not something it owns permanently. This changes how we should think about stability. A fundamental law cannot fail. An emergent phenomenon can. It does not weaken gradually like a dying star. It simply stops appearing when the underlying conditions are no longer met. This means gravity is less like a constant and more like a process. Every moment space-time successfully organizes itself into a geometry that supports curvature, or it does not. As long as it does, gravity exists. If it ever fails, even locally, gravity vanishes completely in that region. There is no half-gravity, there is no weak gravity, there is only curvature or flatness. This also means gravity is not enforced from outside the universe. There is no cosmic regulator ensuring it remains switched on. the universe must continually recreate the conditions that allow gravity to emerge. It must remember how to do so. The unsettling implication is that gravity is not just holding the universe together. Gravity is the universe actively holding itself together. And that act requires coherence. It requires order at a deep level. It requires information to be arranged just right. If that arrangement is disrupted, gravity does not protest. It does not resist. It simply fails to appear. At first glance, this seems impossible. The universe has sustained gravity for billions of years. Stars have lived and died. Galaxies have formed and merged. Black holes have grown enormous. Gravity has never faltered. But this longevity does not prove inevitability. It proves only that the universe has remained within the conditions that allow gravity to emerge. Those conditions may not be eternal. They may depend on global properties of the universe, such as expansion, entropy, or the structure of quantum information itself. This leads to a chilling realization. Gravity does not need to be destroyed. It does not need to be turned off. It only needs to stop being produced. And if that happens, it happens everywhere at once. Not as a wave, not as a signal traveling through space, but as a global failure of emergence, a rule that simply ceases to manifest. To imagine the consequences, we must abandon the idea of gradual decay. We must imagine an instant where the universe forgets how to curve space-time, an instant where geometry relaxes, an instant where gravity is not weakened but absent. In the next part, we will step closer to that threshold. We will examine what conditions allow gravity to emerge and what it would mean for those conditions to fail. Because once gravity is understood as something made rather than something given, the unthinkable becomes possible. For gravity to emerge, space-time cannot be empty in the way intuition imagines. Even the deepest vacuum is not nothing. It seethes with quantum activity. Fields fluctuate, information is exchanged, correlations form and dissolve. Gravity, in many modern views, is the macroscopic shadow of this microscopic chaos organizing itself. Think of space-time as a vast network rather than a stage. Each region is connected to others through threads of quantum information. These connections are not static. They are constantly updated as particles interact, fields fluctuate, and energy moves. When this network maintains the right balance of connectivity, space-time appears smooth, geometry emerges, curvature becomes meaningful, gravity is born. But this balance is delicate. If the underlying informational structure changes too much, geometry loses coherence. Distances stop behaving consistently. Time loses its flexibility. Curvature ceases to be a stable concept. Gravity does not weaken. It stops making sense. One way to picture this is through entropy. Gravity appears to guide matter toward configurations that increase total entropy while allowing local order to form. Stars, galaxies, and black holes are not violations of entropy. They are its engines. But this only works because the universe has room to rearrange information. If entropy reaches a point where no meaningful gradients can form, gravity loses its purpose. There is nothing left to sculpt. Another way to see the fragility is through entanglement. In several theoretical frameworks, space-time geometry is literally built from patterns of quantum entanglement. Regions that are strongly entangled appear close together. Regions that are weakly entangled appear far apart. Gravity then reflects how these patterns adjust when energy is present. If entanglement were to degrade globally, not locally but everywhere, space-time would lose its connective tissue. Geometry would flatten not because mass vanished, but because the relationships that defined distance and curvature dissolved. Gravity would not fade. It would vanish like a shadow when the object casting it disappears. This raises a disturbing possibility. Gravity might depend on the universe staying out of equilibrium. As long as there are gradients, flows, and asymmetries, gravity has something to act on. But as the universe expands and smooths out, those gradients weaken. If the universe ever reaches a state too uniform, too information poor, gravity may no longer have the conditions it needs to exist. This does not require the end of particles or fields. It requires only the end of structure at the deepest level. The universe could remain full of energy and matter, and yet lose the ability to curve space-time. In such a scenario, gravity does not fail locally. There is no region where gravity shuts off first. There is no expanding bubble of flatness. Emergent phenomena fail globally when the underlying conditions fail globally. Gravity would disappear everywhere at once because it is not carried by signals. It is a pattern the universe maintains as a whole. This is deeply counterintuitive, because every other change we know propagates. Heat flows, light travels, forces transmit. But emergence is different. When a pattern stops being supported, it does not retreat, it ceases. Consider temperature again. If every particle in a room stopped moving randomly in the same instant, temperature would not travel away. It would simply be gone. Nothing would need to propagate. The condition that defined temperature would no longer exist. Gravity may be similar. It may exist only as long as the universe maintains a certain level of informational activity and imbalance. If that activity drops below a threshold, geometry relaxes. Space-time becomes flat not as a dynamic response, but as a default state. Flat space-time is simpler. It requires less information to describe. It has fewer degrees of freedom. From the perspective of an emergent universe, flatness may be the lowest effort configuration. Curvature costs complexity. Gravity may be expensive. If the universe can no longer afford that expense, gravity disappears. This reframes the idea of cosmic stability. The universe is not passively obeying gravity. It is actively sustaining it. Every moment that gravity exists is a moment the universe successfully organizes itself into a curved geometry rather than a flat one. This also means gravity has a history. It may not have existed at the very beginning. In the earliest moments after the Big Bang, space-time itself may not have been defined. Geometry may have emerged gradually as the universe cooled and information structured itself. Gravity may have switched on once conditions allowed. If gravity can turn on, it can turn off. This is not a claim that gravity will disappear. It is an acknowledgement that physics does not guarantee it cannot. The equations that describe gravity do not explain why those equations apply in the first place. They assume the universe has already chosen to be geometric. Once that assumption is questioned, the permanence of gravity dissolves. In the next part, we will confront the moment this choice fails, not philosophically, but physically. What happens to matter, motion, and time in the exact instant gravity stops being produced, not gradually, not catastrophically, but completely. The moment gravity stops being produced is not marked by motion. It is marked by silence, not an absence of sound, but an absence of instruction. The universe does not receive an update telling it to behave differently. The update simply never arrives. Space-time relaxes into flatness because flatness requires no effort. Curvature is an active state. It exists only while information remains arranged in a way that supports it. When that arrangement fails, space-time does not resist. It returns to simplicity. At that instant, nothing accelerates. Acceleration requires curvature. What remains is inertia. Every particle continues exactly as it was, following the straightest possible paths through a space-time that is now truly straight. These paths were always there. They were just never allowed. This is why the disappearance of gravity is not dramatic. Drama requires force. Gravity was never a force. It was a rule. When the rule ends, motion continues without correction. The most immediate consequence is the loss of binding. Not destruction, but unbinding. Systems that depended on gravity to define their shape lose the definition itself. A planet is no longer a planet because a planet is not just matter. It is matter following a closed path. Without curvature, there are no closed paths. Stars are no longer stars. Fusion continues briefly because reactions have momentum, but confinement fails. The plasma expands, density drops, temperature falls. The star fades not in a blaze but in a sigh. Galaxies lose coherence almost instantly, not because stars collide or scatter violently, but because there is no longer a center, no reference, no shared curvature to define what it means to orbit anything at all. Each star carries on alone, a memory of rotation encoded in velocity, but no longer meaningful. On the largest scales, the universe becomes eerily uniform very quickly, not because matter disappears, but because nothing keeps it organized. Filaments dissolve, clusters disperse. The cosmic web thins until the distinction between structure and background becomes meaningless. Light still travels. Photons still move at the same invariant speed. But without curvature, light no longer bends. There is no lensing, no focusing. Signals overlap without hierarchy. Information spreads efficiently, but without shape. It becomes noise faster than it can become knowledge. Time itself becomes simpler and poorer. Without gravity, there is no time dilation, no clocks ticking at different rates, no slow, deep time near massive objects, and fast, shallow time far away. Time becomes uniform everywhere, a single rhythm imposed across the cosmos. This uniformity sounds orderly, but it is deadly to complexity. Differences in time flow are one of the ways the universe creates opportunity. They allow processes to unfold at different paces. They allow synchronization and desynchronization. Without them, everything happens at the same rate everywhere. Nothing can hide. Nothing can incubate. Entropy accelerates not because new processes appear, but because nothing slows them. There are no wells to trap energy, no structures to delay dispersion. Entropy does not climb step by step. It slides. Information loses persistence. Every interaction leaves a trace, but the trace spreads too quickly to matter. There are no long-lived records, no archives written into orbits or structures. Memory becomes fleeting. Even the most extreme objects lose meaning. Black holes require curvature to define an inside and an outside. Without gravity, there is no horizon. The distinction dissolves. Whatever information was sequestered is no longer hidden. It is released into a universe that cannot organize it. What remains is not chaos in the cinematic sense. It is something colder, a universe that still moves, still changes, still contains energy and matter, but cannot build, cannot remember, cannot evolve. Gravity was the process that allowed complexity to accumulate instead of resetting. It was the bias that favored persistence over dispersal, direction over randomness, history over immediacy. When gravity stops being produced, the universe does not end. It becomes unfinished, every moment disconnected from the next. Existence reduced to motion without story. In the next chapter, we will explore what happens next, how structure truly dies, how atoms survive briefly but lose their cosmic context, how a universe without gravity becomes a place where nothing new can ever truly begin. There is a temptation to imagine the end of gravity as a single violent event, a snap in the fabric of reality followed by chaos. That image comes from misunderstanding what gravity was doing in the first place. Gravity was never pushing matter together. It was guiding motion through curved space-time. When that guidance ends, nothing reacts. Everything simply continues. The instant gravity stops, the universe does not notice in the way living things notice danger. There is no signal announcing the change, no wave racing outward, no moment that can be pointed to and called the beginning. Gravity does not propagate, so its absence does not propagate either. It is gone everywhere at once because it was never traveling anywhere to begin with. Every object continues along the path it was already on. The difference is that the path is no longer curved. Motion that once traced circles, spirals, and arcs now becomes straight. Straight in the deepest sense. Straight through space-time that no longer bends. Consider Earth in that instant. A moment earlier, it was following a closed trajectory around the Sun, not because it was tethered, but because space-time itself curved the straight path back on itself. When gravity disappears, that curvature relaxes. Earth does not get pushed away. It does not fall outward. It simply keeps going. The curve vanishes, and the straight path reveals itself. From the surface, nothing feels dramatic at first. There is no sudden lift, no lurch. The reason is simple. Gravity was not pulling bodies downward. The ground was pushing upward. When gravity disappears, the push disappears too, but inertia remains. For a brief time, bodies and ground share the same motion. Weightlessness does not arrive as a sensation. It arrives as a delay. Air molecules no longer curve back toward the planet. They drift. Not upward, not explosively, but sideways and outward along straight trajectories that no longer loop back. The atmosphere thins quietly. Sound fades. Pressure equalizes. Breathing becomes impossible before panic has time to register. Oceans do not surge into space. Water spreads. Waves lose their meaning. Without a downward preference, there is no surface. Liquid behavior persists for a short while because molecular forces still act, but the concept of sea level dissolves. The planet becomes a mixing volume rather than a layered world. Inside Earth, gravity had been shaping pressure, temperature, and phase boundaries for billions of years. With that influence gone, the internal structure becomes meaningless. The core is no longer held compressed. The mantle is no longer stratified. Rock, metal, and heat begin a slow unlayering. Not an explosion, a diffusion. Earth is no longer a sphere in any meaningful sense. A sphere is a shape defined by gravity. Without it, the planet becomes a cloud, retaining for a short while the velocities it inherited from its past, then slowly losing coherence. This same story unfolds everywhere. Stars do not blow apart. Nuclear reactions do not suddenly reverse. Fusion continues briefly because reactions have momentum and temperature does not vanish instantly. But gravity was the pressure holding the stellar furnace together. Without it, the plasma expands. Density drops. Fusion rates collapse. Light continues to stream outward, but the source is dying. Each star fades not as a catastrophe, but as a loss of confinement. The brilliance dims. The spectrum cools. Eventually, the star is no longer a star. It is a dispersing cloud of particles carrying energy, but no longer transforming it. Galaxies lose their identity almost immediately on cosmic timescales. A galaxy is not just a collection of stars. It is a pattern of motion sustained by shared curvature. Remove that curvature, and the pattern dissolves. Spiral arms unwind. Elliptical galaxies lose their cohesion. Each star carries on alone, a relic of rotation encoded in velocity, but stripped of context. Even the largest structures ever formed begin to evaporate. The filaments of the cosmic web thin. Clusters drift apart. Voids expand, not because something pushes them, but because nothing pulls matter back. There is no shockwave announcing the end of structure, no visible edge. The universe simply stops correcting deviations. Every imbalance persists, every drift continues. Coordination fades everywhere at once. Light still travels. Photons still move at their invariant speed, but their journeys are no longer sculpted. No bending around mass, no focusing into images, no gravitational echoes. Signals overlap. Contrast diminishes. The sky loses depth. This is the true nature of the instant gravity stops. Not destruction, but release. Not violence, but neglect. The universe is not torn apart. It is unbound. In the next part, we will follow the consequences forward. how the loss of binding accelerates, how structures that seemed independent of gravity begin to fail, how the damage spreads faster than intuition allows, not through force, but through the absence of restraint. The loss of gravity does not stay gentle for long. What begins as quiet unbinding accelerates because gravity was not only holding structures together, it was slowing their unraveling. Once that break is gone, every process that depended on long-lived structure begins to fail faster than intuition expects. Atoms themselves do not immediately fall apart. Electromagnetism still binds electrons to nuclei. Chemistry still works for a time. Molecules still form and break. But atoms never existed in isolation. They evolved inside stars, inside planets, inside environments shaped by gravity. When those environments vanish, atomic behavior loses its context. Consider temperature. Temperature is not just particle motion, it is motion relative to confinement. Without gravity, there are no stable containers on large scales. Heat cannot be trapped. Gradients flatten quickly. Regions that were once hot and cold lose distinction. Chemistry becomes increasingly uniform, increasingly shallow. Radiation floods everything evenly. Without gravity to focus light or trap it in stars, photons spread rapidly. Energy density drops. Reaction rates slow. Complex molecules become harder to assemble and easier to break apart. Not because chemistry changes, but because the conditions chemistry requires no longer persist. Stars that faded earlier now dissolve completely. Their remnants do not collapse into white dwarfs or neutron stars. Those objects required gravity to exist. Without it, there is no pressure balance to maintain them. Matter disperses into thin, expanding clouds. Heavy elements that were forged over billions of years scatter into space without ever assembling again. Star formation stops instantly, not because gas is gone, but because collapse is impossible. No matter how cold a cloud becomes, no matter how dense locally, there is no mechanism to amplify that density. No instability can grow. Every fluctuation is erased by straight-line motion. The universe loses its ability to concentrate matter. Galaxies that once recycled material through generations of stars now become dead archives releasing their contents. There will never be a second generation. No new light sources, no long-lived energy engines. The universe begins to darken, not suddenly, but irreversibly. On larger scales, the cosmic web dissolves faster than expected. Its filaments existed because gravity amplified tiny density differences left over from the early universe. Without gravity, those differences cannot survive. The web thins. The contrast between cluster and void fades. Matter distribution approaches uniformity at a speed that would have taken trillions of years under normal cosmic evolution. Time itself begins to feel different, not because clocks stop, but because nothing meaningful is scheduled. Without long-lived structures, there are no processes that unfold slowly. Everything that can happen happens quickly. Everything that cannot happen never will. The universe rushes toward a flat state, not through violence, but through the absence of resistance. Causality becomes fragile. Signals still travel, but their relevance decays. Without structures to receive, store, and respond to information, cause and effect lose continuity. Events influence others briefly, then vanish into background noise. Nothing echoes forward. Memory fails at every scale. Orbits were memories. Geological layers were memories. Stellar populations were memories. Without gravity, there are no stable records. The universe becomes a place where nothing leaves a lasting mark. Even quantum processes feel the change indirectly. Not because quantum laws depend on gravity locally, but because interpretation does. Measurement requires macroscopic stability. Observation requires persistence. As environments lose coherence, the distinction between system and observer blurs. Reality becomes harder to define in any operational sense. The universe does not explode. It does not collapse. It does not freeze. It thins. It smooths. It forgets. Every moment becomes more like every other moment. Differences fade, history shortens. This is the acceleration phase, the point where losing gravity stops being subtle and becomes absolute, where the absence of a rule reshapes everything faster than any force ever could. In the next part, we will confront the deepest consequence. What happens to space-time itself when gravity is gone? What flatness truly means? And why a universe without curvature may not be able to support time as we understand it. As gravity vanishes completely, space-time itself reveals how much of its character was borrowed rather than intrinsic. Curvature was never decoration, it was function. It defined paths, delays, separations, and limits. When curvature is gone, space-time does not break. It simplifies. And that simplification is catastrophic for meaning. In a curved universe, there are preferred trajectories. Objects follow geodesics that depend on mass and energy. Light bends, time stretches and compresses. Distance is negotiable. In a flat universe, none of this applies. Every path is equally valid. Every direction is equivalent. Motion loses hierarchy. This sounds clean, elegant, but it is sterile. Without curvature, there are no gravitational wells, no places where energy lingers longer than elsewhere, no natural traps for radiation, no regions where processes slow down enough to matter. Everything moves on, evenly and relentlessly. Light still exists, photons still travel, but without bending and focusing, light cannot paint images the way it once did. There are no lenses, no shadows shaped by mass, no depth cues written into the sky. Information arrives flat and overlapping. Signals interfere without structure. Contrast fades. Time becomes uniform in a way it has never been before. In the presence of gravity, time flowed differently in different places. Clocks near massive objects ticked slower. Deep time existed. Shallow time existed. This variation allowed synchronization and delay. It allowed cause and effect to stretch across scales. Without gravity, time loses texture. Every clock ticks the same everywhere. There is no slow corner of the universe, no fast edge. Time becomes a global metronome, indifferent and monotonous. This uniformity destroys opportunity. Complexity requires uneven pacing. It requires some processes to outrun others and some to lag behind. It requires mismatches. Gravity provided those mismatches by shaping time itself. Entropy now surges toward uniformity, not because new mechanisms appear, but because nothing resists it. There are no structures to slow mixing, no compartments to protect order. Entropy does not climb a landscape. It slides across a flat plane. Information disperses almost as soon as it forms. Without gravitational confinement, there is no long-term storage, no archive, no record. Every interaction leaves a trace, but the trace spreads too, quickly to be read. Memory becomes momentary. This is where the universe crosses a threshold. It is still full of motion, but it can no longer accumulate consequences. Events happen, but they do not stack. They do not build. They do not lead anywhere. Even the idea of a future becomes questionable. Not because time stops, but because nothing new can persist long enough to define a direction. The arrow of time weakens, not reverses, weakens. Without gravity-driven structure formation, entropy production becomes uniform and uninteresting. Time loses its sense of flow. Reality approaches a strange stasis while still in motion, a universe that changes constantly, but never meaningfully, like static that never settles into a picture. At this point, gravity is not merely absent. Its absence has rewritten what it means for something to exist. Existence no longer implies persistence. Being no longer implies becoming. This completes the moment. The instant gravity stops is not a flash or a bang. It is a quiet global simplification, a universe that once remembered how to shape itself now, forgetting the rule that made shape possible. In the next chapter, we will follow what little remains of structure as it fades. how atoms briefly survive without context, how stars become impossible forever, and how a universe without gravity becomes a universe that cannot evolve. What remains after gravity is gone is not immediately empty. Matter still exists, energy still flows. Atoms still bind electrons to nuclei through electromagnetism. For a brief cosmic moment, it may seem that the universe has survived the loss of its deepest rule. This impression is misleading. Structure does not die all at once. It dies layer by layer, starting from the largest scales and working inward, stripping context before dismantling components. The universe does not collapse. It thins. It becomes simpler in a way that no force could ever achieve. Atoms are often imagined as self-sufficient islands of stability, protons and electrons held together by electric attraction, quantum rules locking them into discrete states. In isolation, this is true, but atoms were never meant to live alone. They emerged inside stars, inside dense environments shaped by gravity, inside regions where temperature, pressure, and time itself were regulated. Without gravity, atoms still bind, but they drift through an environment that no longer supports chemistry beyond the simplest encounters. Molecules form briefly and then separate. Complex chains struggle to persist. Reaction pathways that once relied on stable temperatures and long-lived gradients lose coherence. Consider a cloud of hydrogen atoms. In a universe with gravity, even the faintest overdensity grows. Particles fall inward. The cloud collapses. Temperature rises. Fusion ignites. A star is born. Without gravity, the same cloud does nothing. Particles pass through one another and continue on. No matter how cold it becomes, no collapse begins. Density fluctuations cannot amplify. The universe loses its ability to escalate simplicity into complexity. This is the true end of star formation. It does not taper off, it stops, instantly and permanently. Every star that will ever exist has already existed. Every heavy element that will ever be forged has already been made. There is no second chance. Existing stars fade and disperse as their internal pressure leaks outward. Their remnants do not settle into compact objects. White dwarfs and neutron stars require gravity to balance internal forces. Without it, there is no equilibrium. Matter expands until only thin clouds remain. Planets lose their meaning next. A planet is not defined by composition. It is defined by gravity, by the ability to clear an orbit, by the ability to hold an atmosphere, by the ability to maintain internal heat through pressure. Without gravity, there are no surfaces, no cores, no skies. What once were worlds become drifting mixtures with no orientation and no history. The cosmic web continues to dissolve. Filaments fade, clusters disperse. On the larger scales, the universe approaches uniformity far faster than it ever would have under normal cosmic evolution. Differences in density shrink. The universe forgets where it once gathered. This loss of structure has a profound consequence for time. In a structured universe, time is busy. Stars burn for billions of years. Planets cool over eons. Life evolves through countless generations. Without structure, there are no long processes. Everything that can happen happens quickly. Everything that requires patience never happens at all. Time continues to tick, but it has nothing to carry forward. No slow arcs, no delayed consequences, no build-up. The universe becomes temporally shallow, a place where moments do not accumulate into eras. Energy gradients flatten. Without gravity, there are no deep wells to store potential energy. Heat spreads evenly. Temperature differences fade. Thermodynamics loses its drama. Entropy still increases, but it does so without landmarks. The arrow of time becomes harder to perceive because nothing marks its passage. What remains is a universe full of ingredients but no recipes. Chemistry without kitchens, particles without places, motion without destination. Structure was not an accident. It was gravity continuously biasing the universe toward togetherness, just enough to let complexity arise. When that bias is gone, the universe does not rage against the loss. It accepts simplicity. In the next part, we will look deeper. How the loss of structure feeds back into space-time itself, how geometry becomes meaningless, and how time begins to misbehave when there are no structures left to measure it against. As large-scale structure dissolves, the universe enters a phase that feels deceptively calm. With galaxies gone and stars fading, there are no dramatic beacons left to mark change. But beneath this quiet surface, something profound is happening. The loss of structure is feeding back into the very framework that once allowed structure to exist. Geometry without gravity becomes increasingly abstract. Distance still exists mathematically, but it loses physical relevance. In a universe with gravity, distance mattered because it shaped delay, effort, and cost. Signals weakened with separation. Energy was required to climb out of wells. Time stretched across space. Without gravity, distance becomes little more than separation without consequence. Two particles far apart are no harder to influence than two particles close together, except for the finite speed of light. There are no regions of privilege, no centers, no edges. The universe loses its sense of place. This has a subtle but devastating effect on processes that once relied on spatial hierarchy. In the past, energy flowed downhill, matter fell inward, radiation climbed outward. These asymmetries created stories. Without gravity, there is no downhill. Energy still moves, but it does not prefer any direction beyond what it inherited from initial motion. Once that motion spreads, there is nothing to replace it. Time begins to feel increasingly hollow, not because clocks stop, but because clocks no longer disagree. In a universe with gravity, time was local. A clock near a massive object ticked slower than one far away. This difference allowed synchronization, problems, delays, and anticipation. It allowed planning. It allowed causality to stretch and fold. Now every clock agrees, perfectly, everywhere. This sounds orderly, but it erases one of the last sources of richness in temporal experience. When time flows the same everywhere, nothing can wait. Nothing can linger. Nothing can hide in slow time while the rest of the universe races ahead. Processes that once unfolded across millions or billions of years are compressed or eliminated entirely. There is no long burn, no slow cooling, no gradual evolution. Everything that happens does so quickly relative to the remaining lifespan of structure. This accelerates the loss of information. Memory requires duration. Records require stability. In a universe without gravity, nothing lasts long enough to be archived. Every configuration dissolves before it can be referenced. The past becomes inaccessible, not because it is erased, but because nothing can hold onto it. Even radiation begins to lose meaning. Photons still travel, but without lenses, without wells, without delays, their journeys blur together. Signals overlap, distinctions wash out. The universe fills with light that carries information but cannot deliver it to a place where it matters. At this stage, the universe is still changing constantly, but it is no longer evolving. Evolution requires accumulation. It requires feedback. It requires memory. Change without memory is noise. This is the quiet death of structure, not an ending marked by destruction, but by irrelevance. Matter still exists, but it no longer participates in narratives larger than itself. Energy still flows, but it no longer powers engines. Time still passes, but it no longer carries stories forward. The universe has not become empty, it has become shallow. In the next part, we will confront the final consequence of this shallowness. How the loss of structure undermines time itself, how entropy and time diverge, and how a universe without gravity approaches a state that feels frozen without ever stopping. When the last scaffolds of structure dissolve, the universe enters a condition that is difficult to describe because nothing comparable exists in human experience. It is not emptiness, it is not stillness, it is a loss of depth. Reality becomes thin in both space and time. Entropy continues to increase, but it does so without landmarks. In the past, entropy growth was visible through events: stars burning fuel, galaxies merging, black holes growing. Each step marked a direction. Now entropy rises through quiet mixing, through the flattening of differences, through the steady erasure of contrast. There are no milestones left to measure progress against. This creates a strange separation between entropy and time. Normally, the arrow of time is defined by entropy increase, by the fact that the future looks more disordered than the past. But when disorder becomes uniform almost immediately, the arrow weakens. Time still flows. Mathematically, but phenomenologically, it loses direction. There is no clear sense of before and after, because nothing significant distinguishes one moment from the next. Imagine a universe where every frame of existence looks almost identical to the one before. Motion persists, particles still travel, interactions still occur, but nothing accumulates, nothing compounds, nothing leaves a durable imprint. The future is not richer than the present. It is merely more of the same. This is what happens when gravity is gone, long enough for its consequences to fully propagate. Not through waves or signals, but through the absence of reinforcement. Gravity once amplified small differences. Without it, differences decay. Every deviation smooths out. Every attempt at structure collapses into uniformity before it can mature. Even randomness loses its power. Randomness matters only when it can be captured, filtered, and built upon. In a structured universe, random mutations lead to evolution. Random fluctuations seed stars. Random encounters spark chemistry. Without gravity, randomness remains random. It produces no trajectories, no selection, no memory. Time becomes something that happens to the universe rather than something the universe uses. There are no schedules, no long arcs, no delayed payoffs. Everything is immediate or never. This has a subtle consequence for causality. Causes still precede effects locally, but chains of causation cannot extend far. Effects do not persist long enough to become causes of something else. Causal chains shorten. Influence becomes shallow. The universe loses its ability to carry consequences forward. At this point, even the idea of a future state becomes abstract. The universe is no longer heading towards something. It is simply continuing. The concept of destiny evaporates. There is no final collapse waiting, no dramatic endpoint, just an ever more featureless continuation. This is why the loss of gravity is more profound than the loss of matter or energy. Matter and energy are ingredients. Gravity was the grammar. Without grammar, words exist, but sentences do not. Events exist, but stories do not. The death of structure is complete, not when the last star fades, but when the universe can no longer tell the difference between change and repetition. When time flows, but nothing meaningful changes. When existence becomes a sequence of present moments with no depth behind them and no promise ahead. This is the universe after gravity. Not destroyed, not silent, but unable to remember what it was or imagine what it could become. In the next chapter, we will step fully into this altered relationship with time. We will ask whether time truly still flows without gravity, or whether something more subtle has ended. Because once structure is gone, time itself may be living on borrowed meaning. When gravity disappears completely, space-time does not shatter, it simplifies. What once behaved like a living geometry, stretching and bending in response to matter and energy, relaxes into something closer to an abstract grid. Not broken, not damaged, but emptied of function. In a universe with gravity, space-time is active. It responds. Mass and energy curve it. That curvature tells matter how to move and light how to travel. Paths are not chosen arbitrarily, they are shaped. A straight line near a massive object is not the same straight line far away. Direction depends on location. Distance depends on history. Without gravity, none of this survives. Space-time becomes globally flat, not just approximately flat, but exactly so. Curvature vanishes everywhere at once because curvature was never stored. It was continuously generated. When the generation stops, nothing remains to maintain shape. This flatness is not the comforting flatness of empty space imagined in textbooks. It is a deeper flatness, a loss of preference. There are no geodesics anymore in the physical sense. A geodesic is the straightest possible path in curved space-time. When space-time has no curvature, every path is equally straight. The concept loses meaning. Motion still exists, objects still move. But their motion is no longer guided by anything beyond inertia. There is no natural arc, no tendency to return, no reason for trajectories to intersect or repeat. Every path is a one-way escape from everything else. In curved space-time, light rays can converge, they can focus, they can form images. Lensing happens because space-time geometry brings paths together. Without curvature, light never meets itself again, unless particles happen to be aimed directly at one another by chance. Images blur into uniform illumination. Vision in the cosmic sense becomes impossible. This matters more than it sounds. Much of what we call information depends on geometry. A picture is geometry. A signal is geometry. A pattern is geometry. When space-time loses shape, information loses structure. Data still moves, but meaning dissolves. Distance itself becomes strange. In a curved universe, distance is not just separation. It encodes effort, delay, and consequence. Far away means harder to reach. Near means easier. Without gravity, distance is reduced to separation alone. Two particles separated by a large gap are not meaningfully different from two particles close together, except for the finite speed of light. This erases hierarchy. There are no centers, no edges, no privileged frames carved out by mass. Everything is equivalent everywhere. The universe becomes radically democratic, and that equality destroys complexity. Time is altered just as deeply. In the presence of gravity, time was flexible. Clocks disagreed depending on where they were and how they moved. This disagreement allowed synchronization problems. It allowed causality to stretch. It allowed anticipation and delay. With gravity gone, time becomes rigid. Every clock ticks at the same rate everywhere. There is no deep time and no shallow time. No place where processes slow down enough to incubate complexity. No refuge where change can hide. This uniform time sounds orderly, but it strips reality of opportunity. Complexity thrives on uneven pacing. Some things must happen fast while others wait. Gravity provided that unevenness by warping time itself. Without it, everything marches forward together, step for step, nowhere to pause, and nowhere to race ahead. Space-time has not been destroyed. It has been emptied of purpose. It still exists as a mathematical arena, but it no longer participates in shaping events. It does not guide. It does not resist. It does not remember. What remains is a universe where motion persists, but meaning does not. Where change continues, but direction is gone. Where space-time exists, but no longer tells matter how to matter. In the next part, we will follow this flattening to its deepest consequence. How information flow changes when there are no preferred paths. How entropy behaves when geometry stops sculpting it. And how time begins to drift away from entropy itself. Without curvature to guide it, information begins to behave in a way that feels alien compared to the universe that came before. In a structured space-time, information followed channels. Light bent, signals focused. Paths overlapped in predictable ways. Geometry filtered noise and amplified relevance. Without gravity, those filters vanish. Information still travels at the same invariant speed. Photons still move. Particles still exchange signals. But there are no preferred routes. No corridors where information is more likely to go or linger. Every signal spreads outward uniformly, thinning as it goes. losing distinction almost immediately. In a curved universe, information could be trapped. It could orbit. It could spiral inward. It could be delayed. These delays mattered. They allowed feedback. They allowed accumulation. They allowed systems to respond to their own past. Without gravity, there is no trapping, no looping, no return. A message sent is a message lost. This changes the meaning of interaction. Two particles may collide and exchange energy, but the consequences of that collision disperse instantly. There is no environment to absorb and store the result, no medium to remember what happened. Cause produces effect, but effect does not persist long enough to become cause again. Feedback dies. This is catastrophic for complexity. Complex systems depend on feedback loops. Stars regulate fusion through pressure. Planets regulate climate through cycles. Life regulates itself through metabolism and reproduction. All of these loops rely on delayed responses. Gravity was one of the main sources of delay. Without it, everything is immediate. Immediate reactions cannot stabilize. They overshoot or fade. Systems flicker instead of settling. Nothing finds equilibrium. Nothing sustains imbalance. Entropy now behaves in a new way. In the past, entropy growth was guided by structure. Gravity created pockets where entropy could increase slowly, dramatically, or catastrophically, depending on conditions. Now, entropy growth becomes uniform and fast. Differences smooth out almost as soon as they appear. This creates a paradoxical state. The universe is far from empty, yet it is nearly maximally disordered almost immediately. Not because energy has spread to infinity, but because there is nothing left to resist spreading. The universe reaches a bland equilibrium without ever passing through the rich intermediate stages that once defined cosmic history. Time begins to decouple from entropy in a subtle way. Entropy still increases, but because it does so uniformly, it no longer provides a clear arrow. The past and future become hard to distinguish phenomenologically. One moment looks like the next. Change continues, but direction fades. This is not time reversal, it is time flattening. Without gravity-driven structure formation, the universe no longer creates new ways to produce entropy. It has exhausted its repertoire. What remains is repetition without progression, motion without development. Spacetime now resembles an arena that has been stripped of its rules. It allows events to occur, but does not shape them. It does not privilege any outcome over another. It does not remember. It does not anticipate. In such a universe, even the concept of location becomes abstract. Being somewhere no longer implies being influenced by that place. Space loses character. It becomes homogeneous, not just statistically, but functionally. This is the cost of perfect symmetry. A universe where every point is equivalent is a universe where nothing special can happen anywhere. Gravity once broke symmetry just enough to let structure form. Without it, symmetry becomes absolute, and absolute symmetry is sterile. Spacetime still exists, but it is no longer a participant. It is a passive backdrop. And in a passive universe, nothing can gather momentum toward becoming something more. In the next part, we will confront the deepest question yet. If space-time has lost its shape and entropy has lost its direction, does time truly still flow? Or has time itself become an illusion sustained only by motion without meaning? When space-time loses its shape completely, time becomes the last familiar concept standing, and even it begins to feel fragile. Clocks still tick, processes still occur, equations still allow a parameter called time to advance. Yet something essential is missing. Time no longer does what time once did. In the universe shaped by gravity, time was not just a sequence of moments. It was a medium in which change accumulated. The past constrained the future. The future differed meaningfully from the past. Events left scars. Structures recorded history. Gravity made this possible by allowing persistence, by letting some things last long enough to matter. Without gravity, persistence evaporates. Moments still follow one another, but they no longer build. Each instant resembles the next so closely that distinction fades. Motion continues, but motion alone is not time in the experiential sense. Time requires a symmetry. It requires processes that are slow enough to compare. It requires things that begin, evolve, and end. Those processes are gone. Entropy still increases, but because it does so almost immediately and uniformly, it no longer defines a clear arrow. In the past, entropy increase was dramatic because it occurred through structure formation and destruction. Stars burned fuel, galaxies merged, black holes grew. Each step marked irreversibility. Now, entropy increase is quiet and featureless. It happens everywhere at once in the same way. The arrow of time weakens not because entropy stops increasing, but because entropy stops being interesting. In this universe, the difference between past and future becomes technical rather than physical. Equations still distinguish earlier from later, but nothing observable changes in a way that gives time weight. There is no anticipation, no memory, no unfolding. This has a profound implication. Time without memory is indistinguishable from noise. If no state persists long enough to be compared to another, then duration loses meaning. The universe is still evolving mathematically, but it is no longer experiencing evolution. Causality suffers the same fate. Causes still precede effects locally, but causal chains cannot extend. Effects dissipate before they can influence anything else. Consequences do not propagate forward through layers of structure because there are no layers left. Causality becomes shallow, limited to immediate interactions that vanish into uniformity. The future ceases to be a place where something different might happen. It becomes merely more of the same. Not because the universe has reached a final state, but because it has lost the ability to differentiate states meaningfully. In such a universe, time becomes redundant. Motion could be parameterized without it. Change could be described without reference to before and after. Time remains in the equations, but it no longer earns its place in reality. This is the deepest loss caused by the disappearance of gravity. Not the loss of stars, not the loss of planets, not even the loss of structure. It is the loss of narrative, the loss of becoming. Gravity was never just shaping space, it was shaping time by giving events consequences that lasted, by allowing the universe to remember where it had been, and therefore move somewhere else. Without gravity, the universe still exists, but it no longer has a story. It is a sequence without accumulation, a process without purpose, a flow without direction. In the next chapter, we will turn to the final repositories of meaning that once existed even in the most extreme conditions. Information itself, memory encoded in matter and horizons, and we will ask what happens to information in a universe where nothing can hold on to it. When gravity is gone and structure has dissolved, time remains only as a faint echo of what it once was. It still advances as a parameter in equations. It still orders events in the most minimal sense, but the role it played in shaping reality has collapsed. Time no longer drives the universe forward. It merely accompanies motion that leads nowhere. In the universe shaped by gravity, time was productive. It allowed differences to grow. It allowed causes to ripple outward through layers of structure. A small event could matter later because gravity gave the universe memory. Stars remembered fuel. Planets remembered heat. Galaxies remembered mergers. Each memory allowed the next stage to occur. Time had leverage. Without gravity, that leverage disappears. Processes still occur, but they complete almost as soon as they begin. There are no long arcs, no slow burns, no delayed consequences. Anything that can happen does so immediately relative to the remaining lifespan of coherence. Anything that requires patience never happens at all. Time flows, but it does not accumulate outcomes. This changes the relationship between time and entropy in a fundamental way. Normally, entropy growth defines the arrow of time. The future is the direction in which entropy increases. But that definition relies on structure. It relies on entropy increasing through identifiable transformations. When entropy increases uniformly and almost instantly, it no longer marks direction. The arrow dulls. The universe still moves from lower entropy to higher entropy, but the difference between states becomes negligible. One moment is not meaningfully more disordered than the next. Entropy rises, but it leaves no footprints. Time advances, but it leaves no trail. In this state, the universe approaches thermodynamic stasis far faster than any classical heat death scenario. Not because it has exhausted energy, but because it has exhausted ways to use energy. Without gravity, there are no engines left, no stars to burn, no gradients to exploit, no compartments to protect imbalance. Time becomes something that happens to the universe rather than something the universe uses. There is no schedule of cosmic events, no future milestones, no waiting. Everything that remains is immediate or irrelevant. This has a disturbing implication. If nothing persists long enough to be compared, then duration itself becomes ambiguous. How long does a moment last in a universe where no state is stable enough to be referenced? Time still ticks, but there is nothing to measure it against except more ticking. In such a universe, time is real but empty. It exists without content, like a clock in a room where nothing ever changes. This is not the end of time in a physical sense. It is the end of time as a meaningful dimension of experience. The universe has not frozen. It has become temporally shallow, a place where the present does not grow into a future that differs from the past. Gravity once prevented this outcome by slowing things down, by creating wells where processes could unfold over long durations, by stretching time in some places and compressing it in others, by making waiting possible. Without gravity, there is nothing left to wait for. In the next part, we will examine how this collapse of meaningful time affects information itself, how memory fails when time cannot hold it, and why a universe without gravity cannot keep records, not even in principle. Information depends on time in a way that is easy to overlook. To store information is to maintain a difference across duration. A memory is not just a pattern, it is a pattern that persists. When gravity existed, persistence was common. Structures lasted, records accumulated. The universe had places where information could settle and remain legible. Without gravity, those places vanish. Information still exists, moment to moment. Particles still carry states. Fields still encode values. But nothing protects those states from immediate dispersal. Every interaction smears information outward at the maximum allowed rate. There are no wells to trap it, no orbits to circulate it, no horizons to hide it. The universe becomes maximally forgetful. This forgetfulness is not due to destruction. Information is not erased in a technical sense. It is diluted beyond usefulness. A message spread infinitely thin is functionally the same as no message at all. In the past, gravity provided natural memory devices. A planet stored information in its orbit. A star stored information in its mass and composition. A galaxy stored information in its rotation and structure. A black hole stored information in its entropy. Each of these was a way for the universe to remember its past states. Now those memories dissolve. Without gravity, there are no long-lived reference frames, no stable clocks anchored to mass, no landmarks in space-time that can be revisited. Measurement becomes ambiguous because measurement requires comparison across time. When nothing persists, comparison collapses. This has consequences even for the idea of observation. An observer is not just a point. It is a system that maintains internal structure long enough to register change. Without gravity, no such systems can exist beyond the most fleeting instants. Observation becomes impossible not because particles cannot interact, but because interactions cannot accumulate into awareness. Information processing dies. This means that even if time continues mathematically, it can no longer host computation in any meaningful sense. Computation requires memory. It requires state retention. It requires separation between steps. Gravity was one of the main reasons those separations could exist on large scales. Without it, every computational process collapses into immediacy. Inputs and outputs blur together. Nothing can be stored between steps. Complexity cannot build. The universe becomes informationally shallow. There is still data everywhere, but no databases. Still signals, but no receivers that last. Still interactions, but no histories. This is where time truly loses its role. A future that cannot differ meaningfully from the present cannot carry information forward. The past cannot constrain what comes next, because nothing of the past remains accessible. Time still orders events, but it no longer links them. In the final part of this chapter, we will ask the unavoidable question: if time flows but nothing persists, is time still real in any physical sense? Or has the universe crossed into a state where time exists only as a parameter with no role left to play? Time can exist without gravity in the same way a word can exist without a sentence. It can be written. It can be defined. It can be placed in equations. But without structure, without memory, without persistence, it no longer participates in meaning. In a universe shaped by gravity, time was woven into everything that mattered. It stretched near massive objects. It slowed where processes needed patience. It allowed cause and effect to unfold across vast scales. Time was not just a background parameter. It was an active ingredient in reality. Without gravity, time loses that role. Moments still follow one another, but they do not accumulate. There is no layering of experience, no deep past pressing on the present, no future pulling events forward. Each instant stands alone, nearly indistinguishable from the next. This creates a strange situation. From the inside, if there were an inside left, nothing would feel like it was ending. There is no final event, no last star going dark that matters more than the one before it, no climax. The universe simply continues in a state where continuation itself has lost significance. Time has become decoupled from becoming. In physics, time is often defined operationally. It is what clocks measure. But clocks require structure. They require repeating processes that remain stable long enough to be compared. Without gravity, there are no such processes at large scales. Any remaining microscopic oscillations cannot be chained together into long-term reference systems. Clocks may tick, but nothing can read them meaningfully. This is the final erosion. Time without clocks, change without memory, motion without narrative. At this stage, the universe has not reached a heat death in the classical sense. Energy still exists. Motion still exists. Interactions still occur. But the universe has reached something more profound. A loss of dimensional richness. Space has lost shape. Time has lost direction. Information has lost persistence. Reality has become thin. This is why gravity was never merely a force. It was the mechanism that allowed time to be thick. It allowed moments to stack into histories. It allowed the universe to experience itself across duration. Without gravity, time still flows, but it flows through nothing that can hold it. Like water poured onto a perfectly smooth surface, it spreads instantly, leaving no trace of where it has been. The universe does not stop. It simply stops, becoming. In the next chapter, we will turn to the last refuge of memory that once existed, even when stars died and galaxies faded, information itself, how gravity once trapped it, how black holes once stored it, and why, without gravity, even information cannot remember itself. In the universe shaped by gravity, information had places to hide. It had places to settle, to linger, to be protected from immediate dilution. Memory was not an abstract concept. It was physical. It was written into orbits, into layers, into horizons, into structure itself. Gravity was the keeper of those records. Without gravity, that role disappears. Information does not vanish. Physics does not allow that. The fundamental laws still conserve it. But conservation is not preservation. Information that is spread too thin is indistinguishable from information that is gone. What gravity once did was prevent that thinning. It slowed it. It localized it. It gave information somewhere to stay. Consider an orbit. An orbit is information stored in motion. It encodes mass, distance, and history. Each revolution repeats the same story. Without gravity, there are no orbits. Motion does not repeat. It does not return. Information that once cycled now escapes along straight paths, never to be revisited. Consider a star. A star stored information in its structure. Its mass determined its lifetime. Its composition recorded earlier generations of stars. Its light carried signatures that could be read across the universe. Without gravity, a star cannot remain a star. Its information leaks away as particles drift apart. The record dissolves. Consider a planet. Geological layers stored billions of years of history. Atmospheres stored chemical memories. Climate cycles stored feedback. All of this required gravity to hold matter in place long enough for records to form. Without gravity, those records never existed in the first place. They are erased before they can be written. At larger scales, galaxies were vast archives. Their shapes remembered collisions. Their rotations remembered dark matter. Their distributions remembered the earliest fluctuations in the universe. Gravity kept those memories coherent across cosmic time. Without it, the archive scatters. The pages fly apart. The story cannot be reconstructed. Even the most extreme repositories of information depended on gravity. Black holes were not just destroyers, they were storage devices. Their entropy measured how much information had been hidden. Their horizons marked boundaries beyond which records could not escape. Gravity created inside and outside. It created secrecy. Without gravity, there are no horizons. There is no inside. There is no outside. Information that was once sequestered is released into a universe incapable of organizing it. Not as a revelation, but as a dilution. Whatever was stored becomes unstructured radiation, spreading into an already forgetful cosmos. This reveals something crucial. Memory in the universe was never guaranteed by conservation laws alone. It required architecture. It required places where information could resist immediate dispersal. Gravity provided that architecture everywhere, from planets to black holes. Without it, information becomes transient by default. This has devastating implications for causality. Cause and effect require memory. An effect must persist long enough to influence something else. In a gravity-shaped universe, effects echoed. They accumulated. They cascaded. Without gravity, every effect fades before it can become a cause again. Causal chains collapse into isolated links. The universe becomes informationally shallow. Events still happen, but nothing records them. Nothing remembers them. Nothing carries them forward. The past ceases to have influence not because it is erased, but because it is inaccessible. Even in principle, reconstruction becomes impossible. In a gravity-shaped universe, one could imagine rewinding history by reading enough records. In this universe, there are no records to read. The information exists only as a diffuse background, with no structure to decode. This is the true end of memory. Not the destruction of information, but the destruction of context. Information without context is noise. Noise cannot tell a story. In the next part, we will confront the last illusion of permanence. Black holes themselves, what they were, what they stored, and what becomes of them when gravity no longer exists to define their boundaries. Black holes once seemed like the final vaults of reality. Even when stars burned out and galaxies faded, black holes endured. They were gravity distilled to its purest form, regions where curvature became so extreme that escape itself lost meaning. They appeared eternal, immune to decay on any timescale shorter than 10 to the power of 67 years. They felt like the last objects standing at the end of time. But black holes were never objects in the ordinary sense. They were features of geometry. A black hole exists only because space-time curves in a particular way. Its defining feature is not mass or density, but the event horizon, a boundary where paths through space-time turn inward so completely that nothing beyond it can return. That boundary is not a surface, it is a geometric condition, and geometry requires gravity. When gravity disappears, black holes do not explode. They do not evaporate in a flash. They simply stop being black holes. Without curvature, there can be no horizon. Without a horizon, there is no inside and no outside. The distinction that defined a black hole dissolves instantly. What remains is not a collapsed object, but whatever matter and energy once contributed to that curvature, now released from geometric confinement. This release is not violent. There is no pressure wave, no blast. The information that was once sequestered behind the horizon does not pour out as a signal. It spreads as unstructured radiation and particles, indistinguishable from everything else. Whatever ordering gravity imposed is gone. This means that even the deepest memory the universe ever had is lost. Black holes were not just sinks, they were ledgers. Their entropy counted the information they hid. Their growth recorded the history of mergers, accretion, and collapse. When gravity vanishes, those ledgers are erased not by destruction, but by irrelevance. The information still exists, but it is no longer stored anywhere. The universe experiences a brief moment of increased radiation density, not as an event, but as a smoothing. Energy that was once concentrated spreads into an already thinning cosmos. The effect is subtle because there is nothing left to notice it. No observers, no structures, no clocks to mark the change. With black holes gone, the last strongholds of persistence vanish. There is nowhere left where information can linger longer than anywhere else. The universe becomes perfectly democratic in its forgetfulness. This completes the erasure of long-term memory. Not just planets and stars, not just galaxies, but even the deepest imprints carved into space-time itself are gone. The universe no longer has a past in any operational sense. It has only a present that cannot refer backward. In the final part of this chapter, we will step back and take in the full consequence. What it means for a universe to exist without memory, without records, without the ability to accumulate history. And why such a universe cannot evolve, no matter how long time continues to flow. With the disappearance of black holes, the last illusion of permanence fades. There is no longer any place in the universe where information can accumulate longer than anywhere else. No vault, no archive, no shadow where history can hide. The universe becomes temporally flat as well as spatially flat. Information still moves, states still change, interactions still occur, but nothing persists long enough to matter. Every configuration is provisional. Every pattern dissolves before it can influence anything beyond its immediate surroundings. The universe becomes a place where nothing leaves a durable trace. This has a profound consequence for evolution in the broadest sense. Evolution requires memory. It requires that outcomes of past processes shape what can happen next. In biology, this is obvious. In chemistry, it is still true. In cosmology, it is unavoidable. Stars enrich gas. Gas forms new stars. Galaxies evolve by remembering their past. Without memory, there is no iteration. Without iteration, there is no evolution. The universe without gravity is locked out of its own future. Time may continue to flow for arbitrarily long durations, millions or billions or trillions of years, but nothing new can emerge. There are no mechanisms left to increase complexity, no way to build upon previous states. The universe cannot surprise itself anymore. Even randomness loses creative power. Randomness only matters when outcomes can be retained and selected. Without retention, randomness produces noise and then vanishes. Every fluctuation is erased before it can be amplified. The universe becomes immune to chance in the most sterile way possible. This is not equilibrium in the traditional sense. Energy still exists. Motion still exists. Interactions still occur. But the universe has reached a state where those interactions no longer lead anywhere. It is a dynamic stagnation, constant activity without progress. From the inside, if an inside could exist, nothing would feel final. There is no ending moment, no last event, no cosmic silence. The universe simply continues in a mode where continuation itself has lost consequence. This is why gravity was never merely about attraction. It was about retention. It was about allowing the universe to hold on to outcomes long enough to do something with them. It was about giving time the ability to build. Without gravity, the universe is not dead. It is forgetful beyond recovery. In the next chapter, we will confront the final state this forgetfulness leads to. A universe that cannot evolve. A universe that cannot generate new structure. A universe that does not explode or collapse, but simply forgets how to change. Black holes were once thought to be the most extreme expression of gravity, places where the universe folded so deeply into itself that even light could not escape. They felt like punctuations in reality, commas where time slowed, periods where causality ended. In a universe with gravity, black holes were not just objects, they were boundaries, they were definitions. Without gravity, they are impossible. A black hole does not exist because matter is dense. Density alone is meaningless without geometry. A black hole exists because space-time curves in such a way that all future paths point inward. That inwardness is gravity. Remove gravity, and the defining condition disappears. There is no horizon. There is no point of no return. There is no inside. This does not mean that the matter which once formed black holes suddenly explodes. It means that the concept of a black hole loses coherence. The mass energy that once contributed to extreme curvature is no longer arranged into a trapped region. It becomes just another distribution of particles and radiation, moving freely through flat space-time. In a gravity-shaped universe, black holes acted as sinks for complexity. They gathered matter. They stored entropy. They locked away information in a way that seemed permanent on any timescale shorter than 10 to the power of 67 years. They felt like the universe's way of keeping secrets, but those secrets were never hidden behind walls. They were hidden behind geometry. When geometry disappears, secrecy disappears with it. The information that was once associated with black holes does not return as a message. It does not reveal the past. It does not restore lost stories. It spreads. Whatever ordering existed is erased by uniformity. The universe does not regain memory. It loses the illusion that memory was ever safe. This moment is not dramatic. There is no flash announcing the end of black holes. No radiation burst that can be pointed to as an event. There are no observers left to notice it anyway. What happens is a quiet equalization. Energy that was once concentrated becomes just another contribution to an already thinning background. With black holes gone, the universe loses the last places where time once slowed enough to matter. Near a black hole, time stretched. Processes unfolded differently. Deep time existed. Without gravity, there is no deep time anywhere. All clocks tick the same. All processes rush or stall together. This erases the final refuge of duration. In the far future of a gravity-shaped universe, black holes would have been the last structures standing. They would have outlived stars and galaxies. They would have marked the slow final chapter of cosmic history. In a universe without gravity, that chapter never exists. The book simply stops accumulating pages. This reveals something unsettling. Black holes were not the end of evolution. They were its continuation. They were part of the universe remembering itself, even as it simplified. Without gravity, even that memory is impossible. What remains now is a universe stripped of its last anchors. No stars, no planets, no galaxies, no black holes, no structures capable of lasting longer than any other. Everything is equally temporary. Everything is equally forgettable. In the next part, we will step back and ask the most difficult question yet. What does a universe like this do next? Can anything new ever arise? Or has reality entered a state where change itself has lost meaning? Once black holes lose their meaning, the universe crosses a quiet but irreversible boundary. There are no longer any privileged places where matter or information behaves differently from anywhere else. No depths, no centers, no final shelters. Everything that exists does so on equal footing, exposed to the same rules, or more accurately, to the absence of rules that once created hierarchy. This equality is not peaceful, it is sterile. In the past, gravity created inequality deliberately. It allowed some regions to be dense and others sparse. Some clocks slow and others run fast. Some paths loop and others escape. That imbalance was productive. It generated contrast. It created opportunity. Without gravity, the universe becomes perfectly fair in the most destructive sense possible. Nothing is favored. Nothing is protected. Nothing is allowed to last. Matter continues to move, but its motion is no longer purposeful. Velocities that once meant orbit now mean escape. Speeds that once encoded history now mean nothing more than direction. Motion becomes a memoryless process. A particle's future depends only on its current state, not on where it has been, because where it has been no longer matters. Radiation fills space evenly, not as a burst, but as a settling. The universe approaches a uniform glow, thin and unremarkable. There are no shadows because there are no objects large enough to cast them. No silhouettes, no contrast. Light loses its ability to outline reality. This is not darkness, it is worse. It is featurelessness. Even the idea of scale begins to erode. In a gravity-shaped universe, size mattered. Big things behaved differently than small things. Mass created curvature. Curvature created new rules. Without gravity, scale loses consequence. A large collection of particles is not meaningfully different from a small one, except in count. There are no thresholds where new behavior emerges. Emergence itself dies. This is the final cost of losing gravity. Not just the loss of objects, but the loss of transitions. The universe no longer crosses boundaries where something new becomes possible. Everything that exists is already all that will ever exist, rearranged endlessly without progression. The future stretches on, but it is empty of novelty. No new stars can ignite, no new structures can assemble, no new processes can arise that were not already present in the first instant after gravity disappeared. Time continues, but possibility does not. This is a universe that cannot surprise itself. From the outside, if an outside perspective could exist, nothing appears wrong. The laws of motion still operate, conservation laws still hold, energy still flows. But the deeper function of reality has failed. The function that allowed change to accumulate into history. In the next and final part of this chapter, we will confront the full implication, what it means for a universe to exist indefinitely without evolution, without novelty, without the capacity to generate meaning, and why this state is not an ending, but something more unsettling. The universe now drifts in a condition that is neither death nor rest. It is activity without direction, motion without consequence, change without accumulation. Everything that once gave reality texture has been flattened, not by destruction, but by perfect indifference. In this state, the universe can continue forever without ever arriving anywhere. There is no final collapse waiting in the distance. No explosion, no silence, just an endless continuation of the same shallow present. The future does not open, it repeats. This is what it means for a universe to be unable to evolve. Evolution is not motion, it is not change, it is the ability for outcomes to matter later. It is the capacity for the universe to build upon its own past. Without gravity, that capacity is gone. Nothing that happens now can shape what happens next in any lasting way. Every moment resets the board. This makes time feel deceptive. From a mathematical standpoint, time advances. From a physical standpoint, nothing progresses. The universe moves through moments the way static moves across a screen, constantly changing yet never becoming anything else. In a gravity-shaped universe, the far future was dramatic in its own quiet way. Stars burned out, galaxies thinned, black holes dominated. Even decay had structure, even endings told a story. In this universe, there is no such arc. There is no late stage, there is only continuation. What remains is not emptiness, but irrelevance. Particles still exist, fields still fluctuate, energy still transfers. But none of it leads anywhere. None of it compounds. None of it produces thresholds where something qualitatively new emerges. The universe has lost the ability to surprise itself. This is more unsettling than destruction, because destruction implies a before and after. This state has no such contrast. The universe does not end. It simply stops becoming. Gravity was the engine of becoming. It was the reason the universe could remember where it had been and therefore move somewhere else. It was the rule that allowed time to deepen rather than slide. It allowed moments to stack into eras and eras into history. Without gravity, reality persists without story. This is the final condition of a universe where black holes have no meaning, where structure cannot exist, where time flows without direction, and where information cannot remember itself. Not a cosmic graveyard, but a cosmic amnesia. In the next chapter, we will step back and confront the full synthesis. A universe that cannot evolve. A universe that does not explode or collapse. A universe that simply forgets how to change. A universe without gravity does not end in fire or ice. It does not collapse into nothing or freeze into stillness. It continues. And that continuation is the most unsettling outcome of all. Evolution is often mistaken for change, but change alone is cheap. Particles move, fields fluctuate, energy transfers endlessly even in the simplest systems. Evolution is something rarer. It is change that builds, change that compounds, change that remembers its own past and uses it to shape what comes next. Gravity was the condition that made that possible. When gravity existed, the universe could climb ladders of complexity. Simple fluctuations became clouds, clouds became stars, stars forged elements, elements assembled into planets, planets developed chemistry, chemistry created feedback, feedback created life, life created memory, memory created meaning. Each step depended on the previous one remaining intact long enough to matter. Without gravity, those ladders vanish. The universe still contains ingredients, but it has lost the ability to assemble them into anything new. Matter cannot gather. Energy cannot pool. Differences cannot persist. Every attempt at escalation dissolves before it begins. This means the universe has entered a phase space with no upward directions. Every possible configuration it can reach is already reachable immediately. There are no distant states that require patience, accumulation, or history to access. The universe has collapsed its own future into an endless present. Randomness still exists, but it has been defanged. In a gravity-shaped universe, randomness seeds novelty. Small accidents grow, tiny imbalances amplify, chance becomes destiny. Without gravity, randomness produces noise and then vanishes. Every fluctuation is erased before it can influence anything else. Chance has no memory to work with. Selection becomes impossible. Selection requires persistence. It requires that some outcomes survive longer than others. Gravity once enforced that inequality. Dense regions lasted. Stable structures endured. Successful configurations accumulated influence. Without gravity, every configuration is equally temporary. Nothing is selected. Everything is forgotten. This erases not only biological evolution, but physical evolution as well. Galaxies once evolved through mergers. Stars evolved through life cycles. Even the universe itself evolved from a hot, dense state to a structured cosmos. All of that required gravity to preserve intermediate stages. Now there are no stages. The universe cannot mature. It cannot age. It cannot enter a late phase distinct from its early one. Time passes, but the universe does not grow old. It remains trapped in a perpetual middle where nothing leads anywhere else. This has a subtle consequence for possibility itself. In a gravity-shaped universe, the future was open. Not everything could happen at once. Some things required long preparation. Some required rare alignments. The future contained states that did not yet exist. Without gravity, all reachable states exist immediately or not at all. Possibility collapses into immediacy. The universe loses its imagination. From a mathematical perspective, nothing is wrong. The equations still run. Conservation laws still hold. Motion is well defined. But physics is more than equations. It is behavior across time. And that behavior has become trivial. This is why the loss of gravity is not just the loss of a force. It is the loss of the engine that allowed the universe to explore itself. Gravity was the reason reality could wander through different configurations instead of repeating the same shallow motions forever. Without it, the universe is complete in the most tragic way possible. Complete because nothing more can be added. Complete because nothing new can arise. Complete because it has forgotten how to become unfinished. In the next part, we will examine what this means for chemistry, environments, and the possibility of complexity at any scale, and why even the simplest forms of organization become impossible in a universe that cannot evolve. Chemistry survives the loss of gravity only briefly, and even then it survives as an echo rather than a living process. At the most basic level, atoms still bind. Electrons still occupy quantized states. Molecules can still form when particles happen to meet. But chemistry is not defined by the possibility of reactions. It is defined by environments where reactions can repeat, specialize, and build complexity over time. Those environments are gone. In a gravity-shaped universe, chemistry had homes. Planets provided surfaces. Atmospheres regulated temperature. Oceans buffered reactions. Pressure and heat created gradients that drove pathways forward instead of backward. Gravity made chemistry directional. It gave reactions a context. Without gravity, there are no surfaces, no sustained pressures, no stable temperatures. Molecules collide in open space and drift apart again. Complex chains break as easily as they form. Reaction networks cannot persist long enough to matter. There is no place for chemistry to settle into habits. This ends not just life, but pre-life. Not just biology, but the conditions that could ever lead to it. Even the simplest forms of organization require repeated interactions in a bounded region. Gravity was the reason regions could remain bounded at all. Environments disappear everywhere at once. A planet without gravity is not a failed planet. It is not a broken world. It is not a world at all. It is a transient arrangement of particles passing through one another. There is no ground, no sky, no interior, no exterior, nothing that can be pointed to and called a place. Place itself was a gravitational concept. Without places, there can be no ecosystems, no niches, no specialization, no division of labor. Every particle experiences the same rules everywhere. Uniformity reigns, not because the universe is empty, but because it is perfectly exposed. This also erases gradients, and gradients are the engines of complexity. Energy flows from high concentration to low concentration. Life exploits that flow. Stars exploited nuclear gradients. Planets exploited thermal gradients. Galaxies exploited gravitational gradients. Without gravity, there are no deep gradients left. Energy spreads too efficiently. Differences collapse too quickly. The universe still contains energy, but it cannot use it. This is the defining feature of a universe that cannot evolve. It is not starved. It is over-smoothed. Everything equalizes before anything interesting can happen. The universe becomes its own worst-case scenario, perfectly optimized for nothing to matter. Even scale ceases to matter. In a gravity-shaped universe, size created new rules. Large masses bent space-time. Large systems behaved differently than small ones. Thresholds existed where new phenomena emerged. Without gravity, there are no thresholds. No matter how many particles you gather, nothing new happens beyond more of the same interactions. Emergence is impossible. This strips the universe of hierarchy. There are no levels of organization. No atoms to molecules, to cells, to organisms, to worlds. There is only particles interacting locally and then dispersing. The ladder of complexity has been removed. Time stretches on, but it stretches across a flat landscape with no peaks left to climb. The universe is locked into a single mode of being, not frozen, but incapable of growth. In the final part of this chapter, we will synthesize what this truly means, not just physically, but conceptually. What it means for reality to exist without the ability to evolve, and why this state is not an ending, but something even more final. When the universe loses the ability to evolve, it loses more than complexity. It loses contingency. In a gravity-shaped cosmos, the present mattered because it constrained the future without fully determining it. Paths branched. Outcomes depended on history. Small differences grew into large consequences. The universe was not just moving. It was choosing, in a statistical sense, among possibilities. That choice is gone. In a universe without gravity, the future is no longer open, not because it is predetermined, but because there is nowhere new to go. Every reachable state is already accessible immediately. There are no distant configurations that require time, patience, or accumulation to reach. The future collapses into the present, and possibility collapses with it. This is not fate, it is exhaustion. The universe still contains motion and interaction, but it has lost its gradients of becoming. Nothing is more likely tomorrow than it was today. Nothing is being prepared. Nothing is ripening. Every moment is complete in itself, and therefore sterile. In this sense, the universe has become timeless without time stopping. Time advances, but it advances across a landscape with no slope, no direction, no asymmetry that can be exploited. The arrow of time has not reversed. It has faded into irrelevance. This reveals the deepest role gravity played. Gravity was not merely binding matter. It was binding moments. It allowed the present to depend on the past in a way that mattered for the future. It allowed history to have leverage. Without gravity, history loses its grip. The universe no longer has eras, no early phase, middle phase, or late phase. It does not age, it does not mature, it does not decay in any meaningful sense. It persists in a state of perpetual immediacy, where nothing accumulates long enough to define a stage of existence. This is why the loss of gravity is more final than any apocalypse imagined. An explosion would still be an event. A collapse would still be a transition. Even a heat death would still be an outcome reached through a process. This is none of those things. This is a universe that has exited the space of stories. It does not end. It does not conclude. It does not resolve. It simply continues without the capacity for anything new to matter. Reality remains, but meaning cannot emerge because meaning requires evolution, and evolution requires memory, and memory required gravity. This is the ultimate consequence. A universe that exists indefinitely but cannot grow, cannot surprise itself, cannot remember itself. cannot become anything other than what it already is. In the next and final chapter, we will step back and gather the full synthesis. What gravity truly was beneath all our equations, why it mattered far more than attraction, and why, when gravity vanished, the universe did not collapse, but dissolved into forgetfulness. When everything else is stripped away, when structure has vanished, when time has thinned and memory has failed, gravity can finally be seen for what it truly was. Not a force, not an attraction, not even a property of matter. Gravity was the universe maintaining continuity with itself. It was the mechanism by which one moment could matter to the next. In a gravity-shaped universe, nothing existed in isolation. Every object carried consequences forward. A star remembered its mass and burned accordingly. A planet remembered its heat and cooled slowly. A galaxy remembered its past mergers in its shape. Even spacetime remembered stress through curvature. Gravity was the rule that allowed yesterday to constrain tomorrow. This is why gravity touched everything without acting like other interactions. Electromagnetism acted between charges. Nuclear forces acted inside nuclei. Gravity acted on existence itself. It shaped the arena in which all other laws played out. It gave them a stage with memory. When gravity existed, the universe was not just a collection of states. It was a process, a becoming, a continuous act of self-reference. Each structure was a note held long enough for harmony to form. Without gravity, that continuity broke. The universe did not lose energy. It did not lose matter. It did not lose motion. It lost persistence. It lost the ability to carry outcomes forward. Reality became a sequence of unrelated presents, each one complete and empty of consequence. This reframes everything we thought gravity was doing. Gravity did not merely pull matter together. It allowed matter to stay together long enough to become something else. It did not merely bend space. It bent time by allowing delay, anticipation, and accumulation. It did not merely trap objects, it trapped information. Gravity was memory made physical. This is why its disappearance was not violent. Violence requires force. Gravity was not enforcing anything. It was allowing structure to remain, allowing differences to persist, allowing time to deepen instead of slide. When that allowance ended, nothing resisted. The universe relaxed into forgetfulness. Every law of physics that felt fundamental depended on this allowance. Thermodynamics required gradients. Gradients required confinement. Confinement required gravity. Chemistry required environments. Environments required gravity. Life required memory. Memory required gravity. Even causality required persistence. Persistence required gravity. Remove gravity, and the universe does not break the laws of physics. It obeys them too efficiently. Everything spreads. Everything equalizes. Everything forgets. This is the final inversion. Gravity was not the weakest influence. It was the most permissive. It allowed the universe to hesitate, to linger, to remember where it had been. And when the universe forgot how to make gravity, it forgot how to remember itself. In the next part, we will complete the synthesis. We will speak directly to what gravity truly was beneath all equations and metaphors, and why without it, nothing can exist long enough to be real. Gravity was the quiet permission slip that allowed reality to slow down. It allowed the universe to resist its own tendency toward instant uniformity. It allowed differences to linger instead of vanishing. It allowed moments to stack, to press on one another, to become history rather than noise. Without gravity, the universe still follows rules, but those rules no longer cooperate to create meaning. Motion persists, but motion alone is not existence in any rich sense. Existence requires endurance. It requires the ability for something to remain long enough to be affected by something else later. Gravity was the reason endurance was possible. This is why gravity appears everywhere without ever announcing itself. It does not shout like an explosion or flash like light. It whispers by staying consistent, by applying the same bias again and again, moment after moment, allowing structure to survive long enough to matter. A mountain exists because gravity allows rock to remain piled instead of spreading. A star exists because gravity allows fusion to persist instead of flickering. A memory exists because gravity allows physical records to survive instead of dissolving. Even identity depends on gravity. An object is an object only because its parts remain associated through time. Remove gravity and identity becomes fleeting. In this light, gravity was never about attraction. It was about commitment. It was the universe committing to its own previous states, agreeing not to erase them immediately, agreeing to let consequences unfold slowly rather than instantly. This makes gravity deeply ethical in a strange cosmic sense. It was the rule that said, outcomes matter, that the universe should not reset itself every moment, that past configurations deserve influence over the future. Without gravity, that ethic vanishes. The universe does not become chaotic. Chaos still has structure. It still has sensitive dependence. It still has memory. This universe becomes something colder than chaos. It becomes indifferent, perfectly responsive, perfectly forgetful. Everything that once felt fundamental turns out to have been contingent on gravity's presence. Stability was contingent. History was contingent. Time's arrow was contingent. Even the distinction between existence and non-existence was contingent on persistence. This reveals the final truth. Gravity was not holding matter together. It was holding reality together across time. And when gravity stopped being produced, reality did not shatter. It thinned. It lost the thickness that allowed experiences, processes, and stories to exist. The universe still exists in a technical sense, but nothing exists long enough to be real. In the final part, we will close the circle. We will return to the beginning and state plainly what gravity truly was. Not as an equation, not as a force, but as the universe's way of holding on. To matter, to time, to meaning itself. Gravity was never just a force acting across distance. It was the universe's way of holding on. Holding on to matter long enough for stars to burn. Holding on to energy long enough for gradients to exist. Holding on to moments long enough for time to acquire depth. Holding on to information long enough for memory to form. When gravity existed, the universe did not merely change. It accumulated. It layered cause upon cause. It allowed consequences to persist. Reality thickened as history stacked upon itself. Each structure was a promise kept from one moment to the next. When gravity vanished, none of the ingredients of reality disappeared. Matter remained, energy remained, motion remained, time continued to tick, but the promise was broken. The universe stopped holding on. Without gravity, matter could not stay gathered. Without gathering, energy could not be focused. Without focus, information could not be stored. Without storage, memory could not exist. Without memory, time lost its arrow. Without an arrow, the universe lost its story. This is the final synthesis. Gravity was not an accessory to reality. It was the condition that allowed reality to be more than a flicker. It was the rule that let existence persist instead of dissolving immediately into uniformity. It was the reason the universe could remember itself long enough to become something new. A universe without gravity does not collapse. It does not explode. It does not end. It simply forgets how to remain itself from one moment to the next. Nothing truly exists long enough to be real. Stars fade not in fire, but in indifference. Galaxies unwind not in violence, but in neglect. Time flows not toward a future, but across a flat present. Information survives only as noise. Motion continues without destination. Change occurs without consequence. Reality dissolves not because it is destroyed, but because it is no longer held. Gravity was never just attraction, it was structure. It was memory. It was direction. It was persistence. It was the universe remembering itself. And without it, the universe does not die. It forgets how to be.